Hi there, Mr. Sutton with the first of two lessons on inverse matrices. In this one, we're going to look at the process for finding inverses of square matrices. So let's talk a little bit about inverse matrices. An inverse matrix, which we have as A inverse, the little negative one up there, that's the matrix whose product with A is the identity matrix. In other words, if you multiply A and A inverse together, you're going to get the identity. Now, why do we care? Well, the identity is an important part of solving systems. So we're going to see later on that there's a very quick and easy way to use inverses to solve a system of pretty much any size that we want. But we're not there yet. Let's talk more about inverses. So to find the inverse of a matrix, we need to first augment matrix A, whatever the matrix is that you want the inverse of, with the identity matrix. So basically, do your little dashed line and write the whole identity matrix on the right side. Next, use row operations to turn A, the left side, into the identity. And then the original identity matrix on the right, when you do this, is going to turn into the inverse. It's kind of cool. We'll see it in action in a minute. Now, just a few notes here. Non-square matrices cannot be turned into the identity, so they don't have an inverse. And if you get a row of zeros during row operations, there's also no inverse. So we'll do this example together. This is a 3 by 3 matrix. Definitely not easy to find the inverse on, but it's good for practice. First step, we're going to augment this matrix, basically just rewrite it with a dashed line and the identity matrix next to it. The identity matrix for a 3 by 3 is going to have 3 of these ones going down diagonally, and then the rest will be zeros. So again, our goal here is to get the identity matrix on the left side using row operations. And then this identity over here is going to turn into something else. That something else will eventually be the inverse. So let's start by getting some zeros here and here, negative 1 and 5. So 2, negative 1, and 5, those all go into 10. So if I make this 2 into a 10 and these numbers down here negative 10s, I can get some zeros. So to do that, I need to multiply row 1 by 5. Row 2 by 10, and row 3 by negative 2. So row 1 then, I'm going to have 10, 10, 0, and now we're changing the identity part of it, 5, 0, and 0. And then for row 2, that's going to be negative 10, 40, 0, 0, 10, and 0. And then for row 3, negative 10, negative 20, negative 6, 0, 0, and negative 2. Now, yes, you guessed it, we're going to add row 1 to rows 2 and 3 and put the answers in 2 and 3. So there's row 1 again. And row 2 now, that's going to be 0, 50, 0, 5, 10, and 0. Row 3, I'm going to have 0, negative 10, negative 6, 5, 0, and negative 2. So here's the matrix from the end of that last page redisplayed here. Our next target, we want to make the 10 and the negative 10 here into zeros. To do that, if I make this a negative 50 and down here a positive 50, then I can add row 2 to those. So I'll have to multiply row 1 by negative 5 and row 3 by positive 5. Row 1 then, I'm going to get, let's see here, negative 10, negative 50 then, negative 50, 0, negative 25, 0, and 0. Multiplying 3 by the 5, I've got 0, negative 50, which is what I wanted, negative 30, 25, 0, negative 10. Now we add row 2 to rows 1 and 3. So we'll have negative 50 up there still, but now this will be 0, 0, negative 20, 10, and 0. Down in row 3, we'll have 0, 0, negative 30, 30, 10, and negative 10. Time to divide. Row 1 will divide by negative 50, row 2 by positive 50, row 3 by negative 30. When I do that, row 1 I've got 1, 0, 0, and now negative 20 over negative 50, we can reduce that to positive 2/5. 10 over negative 50 is negative 1/5. 0 still stays as 0. Row 2 I have the identity, and then dividing by 50 with 5, I get 5 over 50 is 1/10. 10 over 50 is 1/5. 0 over 50 is 0. Row 3, dividing by negative 30. 30 over negative 30 is negative 1, which is nice. 10 over negative 30, that's negative 1/3, and then negative 10 over that is going to be positive 1/3. So this right here is the inverse matrix. If you multiply the original matrix by this matrix, you will get the identity. And just to show what we're looking at, I'll just circle this and put a little A inverse next to it. There we go. Now it's official. These take a while, so we're going to give you some individual practice, but we're going to give you a 2x2 just to get the mechanics down. All right, let's see how you did. So augmenting this, we've got the identity on the right side. That's 1, 0, and 0, 1. Again, we want to make the left side into the identity. So to do that, let's get a 0 down here. If I multiply row 1 by negative 2, I can do that. So that'll be negative 2, 4, negative 2, and 0. Now let's add row 1 to row 2. So this will become, let's see, 0, 1, negative 2, and 1. Next, we need to make this 4 into a 0. So let's multiply row 2 by negative 4. So that's 0, negative 4, 8, and negative 4. Now let's add row 2 to row 1. So we'll have negative 2, 0, 6, and negative 4. Almost there. Let's divide row 1 by negative 2. Divide row 2 by negative 4. So that's going to become 1, 0, negative 3, positive 2. And then 0, 1, negative 2, positive 1. So our identity matrix, or our inverse matrix rather, negative 3, 2, negative 2, 1. Let's take a look at another example, but this time we're going to give you a little bit of an upgrade. So although you can use Gaussian elimination on a 2x2 matrix, there's actually a shortcut formula. It only works on a 2x2 matrix, but sometimes that's all you need. So here's our formula. If you have a matrix in the form of A equals A, B, C, D, whatever those are, the inverse matrix for that, this is going to look a little crazy at first. We're going to have 1 over A times D minus B times C times the matrix, so this is a scalar being multiplied, distributed by a matrix, of dA and negative B and negative C. So this looks a little bit hairy to memorize at first. Here's kind of a little tip for doing it. Notice that everything in this formula works in diagonals. We have AD, that's down diagonal, minus BC, the up diagonal. And then we have the down diagonal, they change places. The up diagonal, C and B change signs. So pause the video and go ahead and apply that to this one right here. See if you can plug in the numbers in the right places. All right, let's see how you did. So we're going to have 1 over, and then we have AD, that's 1 times negative 3, minus BC, so negative 2 times positive 2. Over here, A and D change places. So we'll have negative 3 coming to the upper left corner. 1 goes down to the bottom right. And then up across here, we're changing signs. This becomes positive 2. Down here, we've got negative 2. If you get enough practice with these, it's not a hard formula to use. It's mainly one of those you're going to want to practice it if you know you've got a test on this stuff. All right. So we've got negative 3, and this is plus 4. That all comes out to 1. So we have just 1 over 1. And, well, multiplying 1 by a matrix doesn't change it, so our inverse just ends up being negative 3, 2, negative 2, and 1. It's kind of the best case scenario here. So we did have to use this formula. However, that was fewer steps than doing Gaussian elimination. Pause the video and try this next one all on your own. All right, let's see how you did. Now, I always write out the formula. You don't have to, but I find it helpful. So we've got 1 over... let's see, negative 12 times negative 2 minus 5 times 3, or 3 times 5. And then we've got, let's see, this is going to be negative 2 coming up, negative 12 going down. And then we've got negative 3 and negative 5. So let's evaluate this. This is 24 minus 15, which is, let's see, 9. Distributing 9 to all of these, I'll have negative 2 over 9, negative 3 over 9, which is negative 1/3, negative 5 over 9, and this will become negative 4/3. We'll do one more here. So shortcut formula. Oh, wait, it's already here. So we've got 16 times 1 over 16 times 2 minus 8 times 4. And then we're going to have 2 and 16 and negative 8 and negative 4. So 16 times 2 is 32 minus 32. Hey, wait a second. We've got 1 over 0. What does that mean? Oh, that means this thing is undefined, which means we do not have an inverse for this. Hey, it happens. So that is it for the process of finding inverse matrices. Next time we meet, we'll take a look at some applications of this. Till then, Mr. Sutton signing off.